Okay, we're picking up where we left off. We are still in section 1.3 discussing different ways numerically to analyze quantitative data. We left off where we were talking about the 5-number summary, which consists of the min, Q1, median, Q3, and max. And those 5 values really lead in nicely to what is called a box plot or a box and whisker plot. Okay, it uses the 5-number summary and creates this graphical display called a box plot. And I'm just going to demonstrate that right underneath where I have these written, min, Q1, median, Q3, max. Okay, it says here how to make a box plot. What you do is you make this central box, and it's drawn from the first quartile to the third quartile. So just to illustrate this up here, and by the way, you would have a number line underneath here. That is an absolute must, to have a number line and to have it scaled and labeled with numbers somewhere across there. Okay, but then there is this central box that spans, like the sides, the vertical sides of the box are right where on the number line Q1 and Q3 would be located. Okay, it says then a line in the box marks the median. Okay, now something worth noting, the median does not have to be the very middle of the box. A lot of times you'll see box and whisker plots and that line here is, over to one side of that box there. Okay, so this distance of the box, the length of the box there, that represents your interquartile range, like how much the middle 50% of the data spans. Okay, then it says here lines, we call those whiskers, extend from the box out to the smallest and largest observations, now this is important, that are not outliers. Okay, so it doesn't exactly or necessarily stretch out to the min and the max. It stretches to whatever the largest and smallest numbers are that are not outliers. Okay, if there are outliers in the data set, those are marked with a special symbol like an asterisk. And so you can see in this example right here, these edges at the end of the whiskers are not necessarily the max and min. These asterisks are the max and the min, but they're identified as outliers. Now, I am going to walk through really quickly making some box and whisker plots, but I'm going to be honest, we're going to be using our calculator to make these box and whisker plots. If you have your calculator handy, I trust you do. This is something that we would have done together in class, and it is great because there is a feature when you turn your box plot on the calculator. There are actually 2 that look like a box plot, but if you look closely, one of them shows like a couple dots or something off on the edge. That's always the one you want to pick, because if there are outliers, it'll identify them with little dots or asterisks out off to the side, which is a great thing to know. Okay, so we're going to go back and revisit the data that was giving us like the grams of fat in beef sandwiches at McDonald's and fish and chicken sandwiches at McDonald's. I believe that was this data set right back here. And so I'm going to be pulling like a 5-number summary from this information, the min, Q1, median, Q3, max. We'll do the same thing over here with the fish and chicken. I already did that, and I kind of jotted that information down here. If you can see, that's right here. Okay, so I organized the beef 5-number summary. I just pulled those from the previous page, labeled them as what they represent. I did the same thing over here with the fish and chicken. Now again, I'm going to do this by hand for you right now, but in all honesty, if this was a homework problem and it asked you to take data and put it into a box plot, I do want you to draw the box plot, most definitely, on your paper, but you can let the calculator do the bulk of the work. And so if I were doing that on the calculator, I would enter the whole data set, okay, not the 5-number summary, the whole data set goes into L1 for the beef, and then the entire data set goes into L2 for the fish and chicken, okay? What you would do next, just like when you turn on a histogram or a scatter plot, you would hit second y equals. You would select plot number 1, turn it on. There are 6 types. You've got a scatter plot, another graph, which we'll talk about later, a histogram, and there's 2 that looks like box plots. pick the one that has the little dots you see on the right-hand side. That box plot will identify outliers if they exist in your data set. Okay, and then you're going to go back to second stat plot, pick plot number 2, turn plot number 2 on, and pick the exact same type of box plot. Okay, we are always going to stick, when we graph things on the calculator, we are going to always press that zoom button and pick option 9 for zoom stat. And we won't have to think about a window. It'll give us a great window. It'll show us both of the box plots. Now, when you graph 2 box plots, we call those parallel box plots, okay? So what I'm going to do before I graph these, if I didn't have my calculator and I needed to do this by hand, before I just draw these with the 5-number summary, I need to figure out, are these min and max values, are those outliers? Okay, and so we talked about a rule for how to do this. We would calculate the interquartile range. I believe we did that back, if you look back at the McDonald's example. For beef, it was 8. For fish and chicken, it was 9.5. So I'm going to do my lower fence. My lower fence looks like it would be 9. Ooh, so that is right on the edge, but it would have to be a number smaller, lower than my lower fence to be an outlier. So 9 is not an outlier. Okay, but when I do this, it's Q3 plus 1.5 times the interquartile range. I get my upper fence to be 41, and you can see how the max here is 43. So what that tells me is absolutely the beef max is considered an outlier. Now, when you do parallel box plots, you're going to have 2 different box plots, okay? So I'm going to do the beef one. 9 gets to serve as the very left part of my whisker. What I tend to do is I go through and I make vertical bars for each of the things here, okay? So that's 26, 29. Now here's where I have to be careful. 43, I'm going to put an asterisk. So what I really need to know is I need to know what's the next biggest number next to 43. So I'm just going to scroll back to the beef values here. I can see that was 31. So 31 is where I'm actually going to place like the rightmost whisker. Okay, so these middle ones are my box, whisker, whisker. I can see I got an outlier right there. Okay, and then I'm going to do the same thing here with fish/chicken. Okay, we have to calculate our lower fence. Our lower fence looks like anything smaller than 0.75. Well, 9 is not smaller than 0.75. And then Q3 plus 1.5 times the interquartile range. Anything bigger than 38.75. So it looks like the fish and chicken, there's no outliers. Okay, so when I construct this, then right underneath this, I'm going to do 9, 15, 19, 24.5, and 33. Okay, the middle 3 vertical bars make the box, and I extend the whiskers out. This is the exact same thing that I would see on my calculator. Now here's the thing on the calculator that I made a note of down here. Okay, on the calculator, I think I already talked through most of this here, but then I want to just reference this part. Once you have these pictured on your calculator, if you tap the trace button and then hit like the left and right arrows, your cursor will jump to each of those sections in the 5-number summary. And if you hit the down arrow and then hit left and right, it'll jump and it'll tell you at the bottom of the screen, you know, what each of those values are, which is really nice. Okay. Now the question here was asking us to compare the distributions. So now that I have these distributions, these graphs here to look at, remember we want to use comparative language, and when you see that word to describe the distribution, we want to think CUS. Okay. You can do this in any order. I'm going to go ahead and describe the shape first. Okay, so in terms of the shape, I'm going to say, look, both of these distributions, they appear right skewed. Now, if you're a little confused on that, because it can be a little tricky with a box plot to talk about the shape, let's look a little closer here. If you've got an outlier, that is definitely going to be dragging the data. You can't exactly draw a curve over top like we did on histograms and box plots and even stem and leaf plots, but you got to look at what this is telling you here. There's a big stretch here, there's an outlier. That's definitely right skewed. when you have a longer whisker compared to the other one, and there's no other outliers anywhere, that means it's spanning a wider gap. So this one has maybe like a slight right skew to it. Okay, so they both have some type of a right skew. Okay, now notice here I'm using comparative language. I'm saying the beef has a higher center. Okay, and what I'm using as the center is the median. Okay, the beef has a higher center. The median for that was 26 grams than the fish and chicken, which was 19 grams. Okay, as far as the spread goes, I'm going to say the beef is more variable. There again, I'm using comparative language. It's more variable. That means it's more spread out than the fish and chicken. And I'm going to show what that variable is. It goes from 9 grams to 43 grams, whereas the fish goes from 9 grams to 33 grams. Okay? See how I'm citing the evidence here? I'm citing this by listing some numerical data here. And then finally, the beef has one high outlier, 43 grams, but none for chicken and fish. Okay? All right, so let's take a little closer look here at how you might be able to look at, say, a histogram and put that data into a box and whisker plot. Because we're going to do a little matching activity here at the bottom, but I want to talk through this first because it can be a little challenging here to convert back and forth from a histogram to a box and whisker plot. So I have a sample histogram here. You can see it's somewhat skewed to the right. There are 50 pieces of data in this. Now I realize I don't have my axes labeled here, so I don't have any context for what this is. But what I have listed at the top, these are the frequencies, not the percentages, but 5 pieces of data were here, 8 were here, 12, etc. Okay? So what this means is if 50 people were surveyed, each quartile, that's like 25% of the data, each quartile is going to hold 25% of 50, which is roughly somewhere between 12 to 13 observations will be in each quartile. Because what we're going to attempt to do here is we're going to attempt to roughly convert this into how it might look as a box and whisker plot. Okay, so if we're saying 12 to 13 pieces of data should be in each quartile, then I'm going to go ahead and say maybe right here is the lowest 25% of data, 5 plus 8, that'd be 13. Okay, maybe just this bar in and of itself, 12, that would be the next 25% of data. Okay, I'm going to use all 10 of that and a little bit of that 7 for the next 25%. And then from here I have to span all the way to here to get the next 25% of data. Now here's what we want to think about. The more that the data is closer together, clumped together, like right here, there was a whole set of 25% of the data that was all right here in this section. Okay, so the more the data is together on the left, and the more spread out it is over here on the right. Okay, so when it's closer together, the whisker or that section of your box is smaller. When it's spread out, that's when you get a longer whisker, or it feels like the side of one box is longer than the other. Okay, so this is just rough, but I'm gonna say, okay, this first 25%, you know, it spanned a few pieces of data here, so I'm gonna say maybe that represents the distance, okay? But then the next 25% of data only spanned a little bit. So it didn't take very long because there were a lot of pieces of data there. So I'm going to make that smaller. Okay, the next 25% maybe is roughly about the same width as that. So we'll make this side of the box maybe here about the same width as that. But then look at this last 25% of data. It took a long time to get that last 12, 13 observations stretched out. So that's where maybe that whisker is a little bit longer. Okay, that's what we're going to want to try to do when we do this little matching activity here at the bottom. Okay, we want to try to attempt to match up these box and whisker plots, A through E, with these graphs here numbered 1 through 5. Okay, so you can do this in any order you like. Here's what I want you to keep in mind. Tall bars on a histogram, okay, tall bars mean maybe a shorter section of a box plot. Okay, like if you were going to chunk it into, I know we don't have numerical values like we did on the other example. So I can see here that there's a lot of tall bars on this first graph on the left, okay? And then these are really, really small, okay? So what that means is if I was going to chunk this into 25% sections, most of my data is going to be chunked there, and then it's going to take me all this to accumulate to what would be the equivalent of a stack of another 25%. Okay, this means I'm looking for, maybe a longer whisker here, or even maybe this is an outlier or a few outliers stuck out over here. But I expect maybe those first three parts to be somewhat small, okay? So if you look at what our options are here, okay, maybe an outlier because this is out there, because you can see some of these are showing that there could be outliers. I think a good choice for this would be letter B. Okay, I'm seeing short, relatively short, longer whisker, few outliers. Okay, so that feels like that is a decent match here. Okay, let's go ahead and look here at maybe some of the other ones that have outliers. Maybe we could pinpoint those. Okay, like on A, geez, this is like there's three little outliers there on the left. Okay, if you were to look closely, I think we can agree this is probably the outliers that are identified in that box and whisker plot for A. Okay, so we're going to pick that. Let's see, over here, this looks like we got a little outlier here and a little outlier here. Well, gee, our options are 2, 3, or 4. If you had to pick one of those, I'm probably feeling like that's an outlier. Maybe this one is 2. So I'm going to go ahead and match that up with C. Okay, that leaves me 2 and 3 to be paired up with D or E. Okay. Again, remember, when you've got a clump of shorter bars, that means you're going to have a longer whisker, okay? So maybe the right side would have a longer whisker. See how this is slightly longer, okay? Whereas D feels pretty symmetrical. I think I'm going to go number 2 is D and number 3 is E. Okay. That was not an easy activity there to do in terms of matching, but that's kind of what you would be looking for. Okay, these few review questions here on the next page is going to wrap this up here. We want to know, what is a resistant measure, and is the mean a resistant measure of center? Okay, when we talk about a resistant measure, we mean, does it resist outliers? If you add an outlier into the data set, would that calculation change dramatically? Okay, resistant measures are anything not influenced by outliers, and the mean is not resistant. Okay, it will definitely change if you throw an outlier in there. It is highly affected by extreme values. The median, however, it's very resistant, okay, because the very midpoint position, it's not really affected by what's happening on the outside edges of your distribution. The median is in the middle, okay? Now, this next part is very, very important. Okay, this next part here, it says, how does the shape of a distribution affect the relationship between the mean and the median? Okay, if your data set is symmetric, okay, if it is truly, truly symmetrical, your mean and your median are both the exact same. Okay, if it's symmetrical, that is when the mean and the median are exactly the same. If your data is right skewed, so maybe there's some outliers over here on the right, okay, your mean will always be pulled towards the outlier. So if you're talking about right skewed data, the mean will be greater than the median, and if it is left skewed data, the mean will be less than the median. These ideas right here, you're going to need to go back and read this over, commit this to memory. This is very, very important that you have a good working knowledge of, and here's how I just kind of remember this. The mean is pulled towards outliers. Okay, so it's pulled out into the tail, whereas the median is not. Okay, all right, what is the range? That is simply max minus min. It is a single value. It wants to know if the range is resistant. The range is not resistant. If you throw an extreme value into your data set, it would change what your max or your min is, and that in turn will definitely change your range. Okay, what are quartiles? Quartiles are the 1/4 marks. You find it by starting with the median, and then you find the middle of each half of your data. What is the interquartile range? It's Q3 minus Q1. Again, that is a single value. The interquartile range, like the median, it is resistant to extreme values. Okay, that is not going to be affected at all by outliers. Okay, so to summarize, measures of center. What is resistant to extreme values? The median. What is not resistant? The mean. Measures of spread. What is resistant to extreme values? The interquartile range. What is not resistant is range, and something we have yet to talk about, but we will soon here, something called standard deviation. That's another measure of spread, which we'll discuss, that is not resistant to extreme values. Okay, that is close to where we're going to stop here. On this next page here, we essentially just have a little summary here, which I think we'll come back and we will revisit this after the next section here. Okay, I think that actually this homework here can be completed right now because this page that it's on